This is lesson 20, which is VHDL Example 8. And in this example, we'll design a 4-to-1 MUX like we did in the last example, except in this case we're going to use a case statement. Now, here's the 4-to-1 MUX. Remember this truth table we had. What it says is that if S1, S0 is 0, 0, we want the output to be C0. If it's 0, 1, the output C1. If S1 and S0 are 1, 0, we want C2, 1, 1, C3. Well, we can just use what's called a case statement to basically write this truth table. Here's the case statement, the VHDL case statement. Again, just like the if statement, it must be in a process. Here we have process SC. This is a sensitivity list. The inputs S and C must be in the sensitivity list. If either one of these change, we execute this process. Begin, end process. And then we have the case statement. The case statement says case S is, that is, S can have what values? Well, 0, 0, 0, 1, 1, 0, 1, 1. We list them all. When 0, 0 means when S is 0, 0. Notice these are strings, so we have to have double quotes. If it's just a single bit, remember it was single quotes. For 2 or more bits, we use a string, so it's double quotes here. And then we use this symbol, which is the implies operator, that is equals followed by a greater than sign. So when 0, 0 implies that Z gets assigned C0. See, we're just following the truth table over here. When 0, 1 means when S is 0, 1, Z gets assigned C1. When S is 1, 0, then Z gets assigned C2. And when 1, 1, when S is 1, 1, then Z gets assigned C3. So basically we're just copying this truth table into this case statement. Now you'll notice that we end this case statement with when others implies Z gets C0. I could have put anything here, including the word null we sometimes use. But why do we put when others? Well, we must include all possibilities in the case statement. Now you might think that we've included them all since we had 0, 0, 0, 1, 1, 0, and 1, 1. But which ones have I missed? Well, it turns out we've missed a lot. What type is S? Type is of type standard logic vector. You remember way back in one of the very early lessons we learned what standard logic and standard logic vectors meant. And you remember how many values they had. Yeah, there were 9 possible values, which means that instead of 0, 0, 0, 1, 1, 0, and 1, 1 being all the possibilities, there are really 81 possibilities, because each one can be high impedance, don't cares, and these other ones. So we must include all those, and so when we say when others, we're taking into account all possibilities, and here we just assign it to C0. But these are the 4 that we really care about. Well, if you simulate this program using the case statement, we get exactly the same result we got in the last lesson when we implemented the 4-to-1 MUX using the logic equations or the port map statements, where we made it out of 3 2-to-1 MUXes. So here we let C go 6 and 9 again, and in all cases, if you look at this, it's exactly the same we had before. Z is going to be equal to C0 when S is 0, C1 when S is 1, C2 when S is 2, and C3 when S is 3.